So this shows us that the fuel pump is communicating with our model and that our minimum governor is actually working. So another aspect of hardware loop testing was to check our minimum and maximum governor if they're properly working. For example, we had to see whether our car is reaching our crank states, which we had determined in our minimum max governor models. We had to see if our car reaches run state. We had to see if when we press the pedal, our RPM is increasing properly, and our fuel per cylinder is also being properly injected by the fuel pump. And this oscilloscope basically allowed us just to see if whether the duty cycle signal is being sent from the pedal position to the fuel pump. And that is what we have done over in our hardware and loop testing. We had to calibrate P as and I gains, and we had to calibrate the accelerator pedal position, which later on we moved to the real engine, and we'll be talking about that in the next slide.
All right, let's talk about the engine testing. So this was the core element of this course, and this is where all the things we have learned are integrated. So the objectives before we can do the engine testing was to implement all the previous learnings, all the previous projects learning into this testing. We need to make sure that the Simulink model for this engine controller, which have the minimum and maximum governor, is working in the engine itself. And we need to make sure that we are getting some good graphs for the RPM when the pedal position is changed, and we need to make sure that the graphs are smooth and there's low stability, overshoot and undershoot over there. So for that, our objective was to do some calibration and also fix model if there is some issues. So these were some objectives on the engine testing. Let's talk about the engine testing setup. This is how the program flow looks like on the left. The top three are our model. So the left one have our sensor. The middle one have our controller. Controller have the minimum and max governor, which actually outputs the data to the fuel pump, which can be seen in the actuator, that how much fuel injection needs to be done, and that goes to the engine, and that come back at what engine is in the current state. The picture at the bottom shows the real engine, and this is where we worked on, and the right picture shows the engine control room. This is where the pedal is located, and this is where we flash our model into the ECU, which is located at the engine. Furthermore, on the testing setup, so we use two ECU. Both of them are 48-pin ECU. The first one on the top is the ECU with our developed model, and the bottom one is our CAN gateway model. That CAN gateway model sends signals to the VP44 fuel injector, and that model is already programmed, and the other one, the top one, we program it. And the bottom picture have the fuel pump, and in the fuel pump we have the CAN high and CAN low signals going from the CAN gateway, and this is where the pump inject fuel inside the engine. So let's talk about some initial results. So after I played this video, you will see the initial test results. So this test result is without the calibration, and you will notice it's very unstable. There's a lot of overshoot and undershoot. So our goal for this project was to make sure that we have less than 20 RPM overshoot and undershoot, but it was more than 100 RPM, which will be C. And there was a lot of fluctuation in the injector as well. So let's just play this video and notice what's going on over here. So you can see that it's on the idle state, and the RPM on the idle state is like fluctuating a lot. It goes from 731 to 832, which shows it's like very unstable at this point. So for this, we did some changes. We did calibration. For calibration, we used raw values for the offset and gain, and we implemented using the motor tune. And we also fixed our I gain and P gain, and to make sure that there is no overshoot and undershoot, and the RPM reach point or RPM set point is going smoothly. So these are some things we used, and these are values look like after what we calibrated at the bottom. So This is the graph which shows the final result. So the we start the engine. Now it's on 700 RPM, which shows the minimum governor is working. We accelerated, and the RPM goes to 1700 RPM, which is the maximum point, and then it comes back to the 700 RPM when we release the pedal. So that shows the both minimum and maximum when they're working, and when it's changing the state, there is no stall. Engine is still working. So this indicates the final graph that the program which we created was working and working fine, and we were able to achieve what we were. And on the left axis, we can see the RPMs. So let's talk about some challenges. Obviously, there are like a lot of challenges when you do engineering work, and so the potential problems we had faced earlier was the harness connection. Wiring is very complex part of this process in the control system, because if one or two or like even one wire is not connected properly, then the whole system will not work. The other part was calibration. So you have to work a lot in the calibration. You have to use different values, a lot of troubleshoots required for the calibration. So there was a potential problem while we were working on this. The other thing was the simulating model. So you have to make some changes in simulating model again and again, because there were some instabilities and overshoot, undershoot. So these were some issues we were getting. The biggest blunder we made with was in the final step was the flashing the model in ECU. So the problem the blunder we made over here was, so there are like two ECU, as I told earlier, the one with our model and the one with the CAN gateway model, which is already programmed. So instead of programming our model to the ECU1, we program it to the CAN gateway model, which sends data to the VP44, how much fuel needs to be injected. And it was very hard to find the model for that ECU and reprogram it, so it took some time. So the solving strategies were pretty much same. We used a lot of troubleshooting. We used our bench testing results to see what's going wrong. And then troubleshooting was a greater part, and we did a lot of troubleshooting for this, trying different values and modifying the model. Then the other thing was critical thinking and teamwork. So we need to make sure that everyone is on page. So me and Mashroor worked late as well, and we develop a good communication so we can make sure that we can execute it in a good manner. So these were some challenges part of this project. And now, yeah, thank you for listening to us.